Okay, so today we are going to talk about reflections. So I'm going to start back with transformations. So we're dealing with transformations. We've already talked about those. And specifically today we are talking about reflections. Like the intro video, reflections are a congruency transformation. And what does that mean again? What is a congruency transformation? What it means is that the figure that you start with, or the image that you start with at the beginning, is the same shape and size as the one that you end with. Here's an example. So if we have a coordinate plane, and we're going to make it something fairly obvious. If I have a heart and I reflect about the y-axis. Think about the word about as being the same thing as over. So I am going to reflect it over the y-axis. So if you remember, here's the x-axis and here's the y-axis. So if I reflect it about or over the y-axis, I'm going over the y-axis. And I'm going to explain some more specifics here in a bit. Okay? I have the same image. I'm going to use a different color so you can see. I have the same image, but I reflect about the x-axis. That means I'm taking my figure and I'm flipping it over my x-axis. So I'm going to be going over this way. Let's see how I can do a heart upside down. Okay, so this would be the pre-image, and then depending on which reflection we're doing, you'd be going and creating the image. Some specifics about reflections. And I blow this one up fairly large so you can see the specifics. Okay, so if I have a figure, I'm going to label this as D, E, and F. When you're dealing with reflections, you are looking at the distance it is from what is called your line of reflection. So if we go back up to this one, reflect over the y-axis, your line of reflection here would be the y-axis. For this one, my line of reflection would be the x-axis. So in this one, I'm going to say reflect about the y-axis. So we need to be thinking about distance. So however many units it is from my line of reflection to F, that distance, and remember distance we talk about earlier in geometry, even in algebra, distance is the perpendicular measurement. So whatever perpendicular measurement it is there. So let's say, for example, maybe this is 2 units. Well, then it has to be 2 units the other way as well. And that would be my F prime. However far it is to D, that's how far D prime needs to be as well. And then finally E, it's going to be a little bit harder. So let's say that E has a distance of the green. And I follow the same distance of the green. And there's my, oopsie, not E prime prime. Go back. This is D prime, not D prime. So then if I were to draw my image, there you go. So notice that it is, they are congruent and the distances are the same off the line of reflection. Okay, so you also have to know that you can have other lines of reflection. You can have an x equals 2. You could have a y equals -3. So you need to remember from algebra where your lines actually are. So if we have a line of reflection, and it is y equals 2, you need to know where that is. And so if you remember from algebra, we need to figure out, most people either think that it is running this way at a +2, or it is this way, vertically, at a +2. You need to know the difference. The way that I teach my algebra students is y has to always be 2. So if I were to go back to the very basics and set up my xy table, all of my y's have to be 2. And my x's can be anything. So 0, 1, -3. So if I go and I graph those, 0, 2, 1, 2, -3, 2, you are going to get a line that is horizontal to the x-axis. So y equals 2 is horizontal. So what do you think x equals 3 would be? So like x equals 3 would be a vertical line. Okay? So if we are having y equals 2, and my figure is say if this is D and this is E, if this is 1 unit, so if this is 1 unit away from the line of reflection, then it has to be 1 unit away here as well, and that would be my D prime. Let's say that E appears to be about 4 units. It would have to be 4 units this way as well. So this would be my reflection. The most common error is people will count like 4 units away here, but actually take the 4 units back from an axis and not from the actual line of reflection. Okay? What happens if you are to reflect about y equals x? What is that going to look like? I would have them do the exact same thing here. Create the x and y table. Whatever x is, that is y as well. So 3, this has to be 3. 1, 1, 0, 0. You're going to find that you're going to have a line of reflection. 3, 3, 1, 1, 0, 0. You are going to have a line of reflection going through the origin at a 45-degree angle. Okay? Y equals -x. Remember when we had slope, whatever coefficient was in front of the x, if this was in slope-intercept form, this would be have a negative slope. So we have a coordinates plane. Whatever x is, y is the opposite, or vice versa. I have a room here on my paper. Let me go ahead and switch papers because I'm running out of room. So I have y equals -x, back where we started. So if I create my x and y table, it says whatever y is, x has to be the opposite. Or whatever x is, y has to be the opposite. So if I put a 2 in for x, So that means y has to be a negative 2. If I put a 0, you're going to get a 0. If I put in a negative number, like negative 4, the opposite of a negative 4 is a positive 4. So 2 and negative 2, 0, 0, negative 4, and a positive 4. So you're going to have a line of reflection that is decreasing or has a negative slope. So we will work more with those in class.